Hey guys, welcome back again to another video in our YouTube channel. And today, since we've already kind of given a definition for divergent and convergent series and sequences, we're going to check functions to see if they converge or if they diverge. Remember that converging is where the series come from top. One come from top, does it have to come from top? The other one comes from the bottom and they meet at one value, so they converge. So it kind of makes sense. And divergent is where they just go away from each other, so it's like the words, so it makes sense. So let's look at the first function. So looking at the first function, all we're going to do is to get the limit as n approaches infinity. So we have to expand the top and bottom. So we have n times n squared, plus 8 times n, 8n, plus n times 1n, 8n plus n, 9n, plus 8 times 1, 8, all over n squared minus 10n. So when you're taking the limit to infinity, we just look at the biggest power in both the numerator and the denominator. So both of them have n squared. So as this approaches infinity, so we'll be left with n squared over n squared, which is 1. That means the function go together and to meet at 1, to stop at 1. So they go to stop at 1. Since it goes to stop at 1, that means this function converges. Moving on to the next one, we do the same thing. Check as n approaches infinity. So as n approaches infinity, which of these will get bigger? Is it e times n or e raised to power n? This e raised to power n will obviously grow way larger than e times n. So we have this function being top heavy. So this, as n approaches infinity, this function goes to infinity, which means it's going to nowhere. It's basically going to the sky. So which means this function diverges. Then for the last one, this function interchanges from -1 to +1, -1, +1, and it goes like that. So it doesn't really go to stop at a particular value, as we say that functional converges does. It just goes from -1 to +1. So we can say that this function diverges. So that's it for this video. See you guys in the next one. Thank you.